In this video, we're going to be describing and interpreting functions. All right, recall from earlier lessons that the domain is the set of all inputs for a function, which is the x values, while the range is the set of all outputs for a function, which is the y values. Okay, so in our first example, it says to list the domain and the range of the function defined by the set of ordered pairs shown below. All right, we have these collection of points 0, 5, 2, 7, 3, 11, 7, 4, and 10, 5. To list the domain and the range, we're going to open up a set of braces here. And then again, your domain is the inputs, which is all of the x values. So we're going to list them in numerical order. All right, and so 0, 2, 3, 7, and 10, and then we close it with a brace there. Those are all of the input values, the x values of each point in my set, okay? The range, again, we'll open up the braces, are the y values, the output values, and again, we're going to list them in numerical order. So 4 is the smallest number in the range, and then we have the number 5. Notice that 5 shows up twice as a y value, as an output value, but we only need to list it once. And then that's going to be followed by 7. And then the biggest number in the range is 11, which we see right there. Okay, so these are the domain values, the x values, the input values, and these are the range values, which are the output or the y values. And then the question asks, if the point 2 comma 1 was added to the set, would the set still be a function? Why or why not? Okay, so if we were to add 2 comma 1 into this group up here, do we still have a function? Well, 2, it would be one of my domain values still. Okay, I still have that value here. I would have to add 1 to my range values, which means that the input value of 2 would actually map to 2 different y values, which would make this not a function. So if the point 2 comma 1 is added to the set, then the set is not a function. Then the set, let me rewrite that, then the set is not a function because the input value 2, the input value of 2 maps to 2 different output values. Okay, we stated in an earlier lesson that a function has one output for every input, all right? Every input has only one output. If we add 2 into this set here, then 2 maps to 1, but 2 also maps to 7. So the input value 2 would map to 2 different outputs, making this not a set. All right, so here we have a graph of a function, and I know that this is a function because if I were to use the vertical line test, any vertical line that I would draw through this function would only hit the function in one place. So this is definitely a function. And oftentimes the behavior of the function is discussed. When we talk about the behavior of the values of the function, we're always referring to the outputs. And the outputs, again, are your y values. So in this example, all right, the graph shows that y is a function of x, all right? Use the graph to answer the following questions. What is the maximum value that the function reaches? Well, again, they want to know what the highest output is going to be when they want the maximum. Maximum means the highest, and if we're talking about the maximum value, we want to know what's the highest output. So we're looking for the highest y value. Remember that your y-axis runs vertically right here. And so we're looking for the point that's going to be highest up on this graph, which we can see is right here. Okay, this point is found at 7 comma 8. 7 comma 8 is that point right there. All right, what is the maximum value? Well, that's when y is equal to 8. Okay, your output value, your highest output is at y equals 8. And at what input does the function reach that maximum value? We get the output value of 8 when we have an input or an x equal to 7. Okay, so 7 comma 8 means that the input value was 7, and it gave us a maximum value of 8 as the output. What is the minimum value that the function reaches? So again, minimum means the smallest in this case. What's the smallest output? Well, that's going to be the lowest point on our graph, which we see right here. And that's at 1 comma negative 4. So the minimum value is when y equals negative 4. And the input value that gives us the minimum value is when x is equal to 1. All right, the input value of 1 gives us the minimum output value of negative 4. Letter E asks, is the value 10 in the range of the function? And again, range meaning your output values or your y values in this example. So here is y equals 10 right here. Is there any point where our function reaches this value up here? And we can see, well, no, the maximum right here is when y equals 8. We never get to a y value of 10. So we can say, no, there is no input value. There is no input value that maps to an output of 10 on the graph. Okay, there is no input value that maps to an output value of 10 on our graph. So 10 is not a member of the range in this example. So we just saw in our previous example that the maximum represents the highest y value on the graph or in a table or in a set of ordered pairs, while the minimum represents the lowest y value. We're also interested in the behavior of the function between different intervals. Is the function increasing, meaning it's getting higher, or is the function decreasing, meaning that it is getting lower as the input values increase? Now remember that the input values are your x values. We're looking at when the input values increase, as your x values increase. Well, in order to determine this, where the x values increase, you always have to read a graph going from left to right, the same way that you would read a sentence, all right? As you move from left to right on a graph, your input values, your x values are increasing. All right, remember that your x-axis is just a number line, and as you move to the right on a number line, your numbers go up. So in this example, we've taken the same function that we were working with before, and this graph, this function, has 4 distinct intervals. We're going to use this graph to determine the behavior of the function, namely saying if it's increasing or if it's decreasing. The first place that we're looking is between when x equals negative 4 and when x equals negative 2. Now, we could write this using something called interval notation. We want all x values that are between negative 4 and negative 2. That's what this means, between negative 4 and negative 2. So negative 4 has to be less than x, and x has to be less than negative 2. We're looking at all places in this interval between negative 4 and negative 2, all x values. So if we go on our graph and we find where x equals negative 4, well, that's this point right here. And then if we find when x equals negative 2, well, that's this point right here. And if we move from left to right, going from this point to this point, notice that the function is moving up, so we can say that the function is increasing. This is an increasing function between x is negative 4 and x is negative 2. What about between x is negative 2 and x is positive 1? Well, again, with interval notation, we want all x values that are between negative 2 and positive 1. So negative 2 is less than x, and x is less than 1. So here's where x is negative 2, and here's where x is 1. And if we move from left to right, from this point to this point, notice that the function is decreasing. It's moving down this time. This is a decreasing function between x is negative 2 and x is positive 1. What about between x is 1 and x is 7? Well, again, in interval notation, 1 has to be less than x, and then x has to be less than 7. So x is between 1 and 7. Here's when x is equal 1, and here's the point where x is equal to 7. And notice that as we move from left to right, the function is going up. It's getting higher. It is increasing. This is an increasing function between x equals 1 and x equals 7. The fourth interval in this that we're going to look at is between x is 7 and x is 10. 7 is less than x and x is less than 10. Here's where x is 7 and here's where x is 10. And as we go from left to right, the function is going down. The function is decreasing between x equals 7 and x equals 10. Okay, now in this graph, the location where the function changes direction is known as a turning point. State the coordinates of all turning points in the graph. Okay, so if we go from left to right, the function starts right here. All right, nothing happened yet, so this is not a turning point. That's actually the starting point. We move from left to right, the function is moving up until it gets to this point here where it changes direction and starts to move down. So this is a turning point, and it's found at -2, 5. So -2, 5 is the first turning point found here. Then the function decreases until it reaches this point where it again starts to increase. So this is the second turning point, and that's at 1, -4. 1, -4 is the second turning point. The function increases again until it reaches this point up here where it again starts to decrease. So this is a third turning point, and that's when x is equal to 7 and y is equal to 8. 7, 8 is a third turning point, and then the function decreases until it reaches the end found right here. This is the end of the function, but it's not a turning point. So the three places where the graph changes direction is at -2, 5, 1, -4, and 7, 8. In the graph of the function that we've just been working with for the last few examples, notice that some parts of the function are straight while other parts are curved. This leads to a good discussion about the different types of functions. With this year, we're going to be working with linear functions and nonlinear functions. Linear functions are functions whose graph form a straight line. The root word of linear is line. Linear functions form a straight line. Nonlinear functions are functions whose graphs do not form a straight line. No line is nonlinear. They are going to be curved. Is the function shown above linear or nonlinear? Well, let's look at each interval that we saw before. Okay, between x is -4 and x is -2, the function is increasing from here to here, but notice it's not increasing in a straight line, it's curved. So this is increasing and non-linear. Between x is -2 and x is -1, the function is decreasing. And again, it's not decreasing at a constant rate. It's not in a straight line. So this is decreasing and nonlinear. All right, the function is curved between x is -2 and x is 1. Between x is 1 and x is 7, the function is increasing. And notice it's increasing at a constant rate. It's a nice straight line. This is increasing and linear between x is 1 and x is 7. And then between x is 7 and x is -10, it's decreasing, but it's curved. It's not decreasing in a constant rate. This isn't a straight line. So this is decreasing and non-linear. And so that's the different intervals. But if we look at the function as a whole, working from left to right, this is a non-linear function because it has many curves in it. There's only one straight part here. For the entire function to be linear, the whole thing would have to be a straight line. So this function is non-linear because it curves in many places. All right, this year we're going to be studying linear and nonlinear functions more in depthly as we progress throughout the material. Remember that you read a graph moving from left to right, just like you would read a sentence. If a graph is moving up as you go from left to right, then the function is increasing. Okay, but if the graph is moving down as you go from left to right, then the function is decreasing. All right, and if the function is increasing or decreasing at a constant rate, it's going to look like a straight line. All right, these three graphs show increasing linear functions because as you move from left to right, they increase at a constant rate, so they look like straight lines. These three graphs are decreasing linear functions because as you go from left to right, the function goes down at a constant rate or in a straight line. Okay. Nonlinear functions, however, are going to be curved. You can see the different curves in these functions here, meaning that these are nonlinear. So moving back into the box, if a function curves, then the function is nonlinear. Nonlinear functions curve, but linear functions will always form straight lines. In our next example, we're going to use the graph of this function to answer some questions. The first thing that they want is the maximum and minimum values of our function. So again, the maximum is going to be the highest y value, while the minimum is going to be the lowest y value. And looking at this graph, the highest it reaches is this point right here, which is at 1, 2, 3, x is 3, comma, y is 6. So the maximum has a y value of 6. The lowest that the function reaches is at this point right here, and that's going to be at the point 7 comma negative 8, 7 comma negative 8. So the minimum is when y is equal to negative 8. Okay, remember that they're looking for the output values here when you've got your maximum and your minimum. Letter B, state where the function is increasing and use interval notation. Where is the function increasing as we move from left to right? So here we are at the beginning, okay? And so the function starts right here, and as we move from left to right, it increases until you get to this point right here. Okay, so what are the x values, the input values for each of those points? Well, this x value here is at negative 9, and this x value here is at negative 7. So all x's that are between negative 9 and negative 7 show an increasing function. Okay, between negative 9 and negative 7, the function increases. Then the function decreases until it reaches this point right here, at which point it increases again until it reaches this point here. So what are the x values this time? Well, this is an x value of negative 3, and this is an x value of positive 3. So all x's that are between negative 3 and 3 will have an increasing function as we move from the left to the right. It increases. The function then decreases again until it reaches this point right here, and that's your minimum point again. And then the function again starts to increase until it reaches this point right here. So what are those x values? Well, I know this x value is 7, and this x value right here is 9. So all x values that are between 7 and 9 also show where the function is increasing. So there's 3 intervals where the function is increasing. Letter C, state where the function is decreasing using interval notations. Okay, so just like we did before, now we want to know where it's decreasing. So back to the beginning, it's increasing until we reach this x value here, and then it decreases until this x value here. So it decreases from x is negative 7 until x is negative 3. So from negative 7 to negative 3, the function is decreasing. The function increases again until it reaches x equals 3, and then it decreases again until x equals 7. So between x equals 3 and x equals 7, the function is decreasing, and then it increases again to the end. So 2 places where the function is decreasing. List the coordinates of the turning points. Where does the function change direction? So here's the starting point. It changes direction at this point right here where it starts to decrease. So that's at negative 7 comma 4. Negative 7 comma 4 is the first turning point. The function decreases then until it reaches this point where it starts to increase again. This is at negative 3 comma negative 4. Negative 3, negative 4 is the second turning point right here. It increases again until it reaches this maximum point, which we said before was 3 comma 6. That is the next turning point. And then it starts to decrease again until it reaches this point down here, which was our minimum, and that was at 7 comma negative 8. That's the fourth turning point, and then the graph reaches the end. Okay, so those are the 4 different turning points where the function changes direction. And then finally, is the function linear or nonlinear? How do you know? Well, again, linear means that it's going to be a straight line. Nonlinear means that it is not a straight line. And clearly looking at this as we move from left to right, this function curves in many places. This is a nonlinear function. The function is nonlinear because it curves in many intervals. The graph is only linear from the interval between -3 and +3. All right, between -3 and +3, those are the input values where the function was linear. But as a whole, this function is nonlinear because it curves in many different intervals.